Hello everyone, my name is Sung Young-seo and I am a sophomore majoring in Climate and Energy Systems Engineering. As you already seen in the title, I did test it and check the equations we learned about static atmosphere. But I was originally going to prepare a review presentation covering structures of the static atmosphere. So I reviewed the concepts and equation we learned in class. I also posted the concept on blog, so in case you're curious, please check it out via QR. But then I got really curious. I really wanted to see if those equations actually work in real life. So you might be wondering, what was I doing up there? I went outside and measured the air pressure and altitude at 3 different points on our campus: the front gate, the Research Cooperation Building, and the Engineering Building. After that, I plugged my measurements into these equations. First, I calculated the scale height, which is given by this equation. I plugged in 287 joule per kilogram Kelvin for R, 9.8 meter per second square for G, and 295.61 Kelvin for the temperature. Then I was able to get 8,657.15 meter for the scale height. So if you go back to this equation, this means that each time the altitude increases by about 8.7 kilometers, the air pressure decreases to about 1 over E, or roughly 37% of its original value. I set 0.1 for the front gate and 0.2 for the Research Cooperation Building. Then I got these results. So I was able to calculate ZT, which represents the thickness of the air layer between 2 points. And it came out to be 72.134 meters, while the actual height was 73.8 meters. These two values are actually really close, and I honestly didn't expect the difference to be this small, especially since we had to assume the air was isothermal. Even though the difference was only about 0.9%, I really wanted to make it even smaller. So I considered the virtual temperature since it was a humid day. This is the corrected temperature I got, and with that correction, the calculated air layer thickness became 72.883 meters, which matched the actual value even closer. So lastly, I drew a graph to check if my 3 measurement points fit the theoretical curve. I used GeoGebra and confirmed that my measurements align beautifully with this exponential decay curve. This experiment showed that the equations we learned in class really do describe the real atmosphere quite accurately, even with simple measurements taken right here on our own campus. And one more thing, I was surprised to find out that the air pressure on the Research Cooperation Building was about 8 hectopascal lower than it was at the front gate. So to put that into perspective, 8 hectopascal corresponds to the weight of about 80 kilograms of air pressing on 1 square meter. So next time when someone asks,
"What's so special about the Research Cooperation Building?"
we can proudly say it's the place where the air above you weighs a lot less. Thank you for listening to my presentation, and I hope you all have a happy Chuseok.